In this question, we have to give the reason for the given statements. The first one is copper 1 compounds are white whereas copper 2 compounds are colored. This 1 and 2 means the oxidation state, they are +1 and +2. So we know that the oxidation state of copper, that is +1 and +2 here, and the normal electronic configuration of the copper, that is the ground state electronic configuration of copper is 3D10 4s1. Now I am moving to the Cu plus ion. So the electronic configuration will be 3D10 and Cu2 plus ion have electronic configuration 3D9. Now the color of the d block elements or these transition elements are due to the process that is called dd transition. It means the d electrons from the ground level will excite into the higher level. That's why they are colored. So if the dd transition is absent among any ion, they will be colorless normally. So here you can see in case of Cu plus ion, 10 electrons are there. So 10 electrons means all the electrons will be paired, means there are no unpaired electrons. So there is no dd transition or electronic excitation. So the compounds containing Cu plus ions will be colorless. At the same time, if you are moving to Cu plus 2 ions, they have the configuration 3D9. So we can see the electronic configuration will be like this. It means they have one unpaired electron. So this one unpaired electron is responsible for dd transition, and this dd transition will cause the color of these copper 2 ion compounds. Next one, chromate changes their color when kept in acidic solution. So in acidic solution, the chromate ions, they are CrO4 2-, they will changes to Cr2O7 2- ions. Chromate ions have one color and the dichromate ions have another color. So in acidic medium, this conversion is happening. That's why they are showing different color in acidic medium. Next one, zinc, cadmium and mercury are considered as d block elements but not as transition elements. So according to the definition for transition elements, we can say the elements which have the partly filled d orbitals in its atomic state, means ground state or ionic state, is considered as transition elements. Suppose the first example, I am moving to zinc. They have electronic configuration that is 3D10 4s2. So here you can see the d subshells are completely filled, means there is no unpaired electron. So the d orbital is completely filled, not partly filled. Next one, if you consider the oxidation state of zinc, the common oxidation state is +2. So the electronic configuration will be 3D10. So here again you can see all the electrons in the d orbital are paired. So in zinc and Saturn 2+ ion, both of them have completely filled d orbital, not partly filled d orbital. So they are not considered as transition elements, but they are belongs to the d block. Next one, we have to calculate the magnetic moment of Cu2+ ion by using spin-only formula. We have the formula, spin-only formula, that is the magnetic moment mu is equal to square root of n into n plus 2. Here n is the number of unpaired electrons. Okay, first we are moving to cobalt. The cobalt, that is the atomic number 27, have electronic configuration 3d7 4s2, and cobalt 2+ means they have electronic configuration 3d7. So we are moving to the box diagram. It will be like 1, 2, 3, 4, 5, and electrons will be like each orbital will be singly occupied and two orbitals will be completely occupied, means they are paired. So here we can see three unpaired electrons are there in CO2+ ion. So the magnetic moment mu is equal to square root of 3 into 3 plus 2, that is square root of 3 into 5, that is square root of 15. The value will be equal to 3.92 Bohr magneton. Now we are moving to the second part of the question. Here, the first question is 3 points of difference between lanthanides and actinides. The first one we can see the lanthanides are not radioactive or they are non-radioactive elements. At the same time, actinoids are radioactive in nature. Next one we can see in case of lanthanides, they do not show wide range of oxidation state, do not show variable oxidation state. But in case of actinoids, we can see they show variable oxidation state. The next point we can see that most of the ions of lanthanide ions are colorless. At the same time, the actinides, the ions are colored. Okay, you can write any 3 points. So these are the 3 important differences between lanthanides and actinides. Next one, give reason and select one atom or ion which will exhibit asked property. So the first one is given as scandium 3 plus or chromium 3 plus. Which one exhibit magnetic, that is diamagnetic behavior. So first I am writing scandium, atomic number 21, that is 3D1 4s2, and scandium 3 plus ion have electronic configuration, that is that of argon only. There is no electrons in 3D orbital and 4s orbital. Now we are moving to the next one. Chromium have electronic configuration 3D 5 4s1, and now the chromium 3 plus ion have, one will move here, two will move here, so it will be argon. Now 3D 3 configuration. Next one, if you write the electronic configuration in box diagram, you can see in case of chromium, here 3 unpaired electrons are there, means they are paramagnetic in nature. But in case of scandium, there is no electrons in d orbital and s orbital in scandium 3 plus ions. Only the electronic configuration corresponding to argon will be there, means all the electrons are paired. So scandium 3 plus is the diamagnetic ion. Next one, chromium or copper, which one have high melting and boiling point? We know that if you compare chromium and copper, chromium have high melting and boiling point because of the strong intermetallic interaction is there between chromium atoms or chromium particular individual chromium ions than that of copper. So the intermetallic interaction is higher in chromium, means the metallic bonding is strong in chromium. That's why they have high melting and boiling point.